A large benefit in the application of UAVs comes when you can operate them autonomously. For this, you need a dedicated maintenance concept so that you're able to detect degradation and damages remotely without having a person interfere into the operation. This is why we are working on inspection and condition monitoring of UAVs to detect these kinds of degradations and to really enable this autonomous operation.
The Vertiport is a structure that gathers external data from a drone to be able to analyze and evaluate its condition. So we have set up several cameras, including an infrared camera, a camera from the top, 2 cameras from the bottom, and a scale that measures the weight of the drone. And with that, when the drone lands, we can gather some information.
And of course, during the flight, there might be some occurrences, some events that, for example, the battery needs to be recharged or propeller needs to be exchanged, then the MRO will take over.
The UAVs are built quite simply. They mainly have the propulsion system and the energy storage, usually a battery, as those components which are subjected to the most degradation or which can be damaged easily. That's why we are focusing on these components for condition monitoring. We do that by analyzing the onboard data, the behavior of the UAV in flight, but we're also looking at it using external sensors like microphones in order to record the acoustic signature of these vehicles as they land.
The acoustic measurements are made to detect a faulty propeller or a broken propeller because the sound of a broken propeller is different to the sound of a healthy propeller. It has a different pitch, it has something different to it that you as a human can also hear, and so we used AI to try to imitate the human and be able to hear the difference between a healthy and a broken propeller.
One aspect of future MRO is actually that we want to be able to trace all components and how they build up or integrated into drones. The main idea behind this is the digital twin. So with the concept of digital twins, we are able to track, to know how long a certain component is or was integrated to a drone, what it was exposed to, what kind of circumstances or conditions, the weather, the maneuver loads and so on. And with that enables us to go towards predictive maintenance, that we can make the best use of the lifetime. We understand the drones as a technology platform to develop our own methodologies and to test as much as possible. With the help of the drones, we are independent and we can generate our own data, and we can also create our own flight missions.
We see a big potential, especially for small UAVs, to make aviation environmentally friendly, especially when it comes to replacing flights which are currently done by helicopters with electrically propelled UAVs, for example, for the inspection of infrastructure, or also as an enabler for applications like precision farming, where you could have an even bigger leverage to gain an environmental impact. In Cochstedt, we have an entire airport for us. So we have ideal conditions to do flight experiments. We can do flights at longer ranges without disturbing anybody. We can operate our UAVs here safely and gain all the data which we need to build our condition monitoring.